Right now, in the Pacific Ocean, a climate event is developing that scientists are already comparing directly to the deadliest environmental disaster in modern recorded history. Between 1876 and 1878, an extraordinarily powerful El Niño triggered a chain of simultaneous droughts across 4 continents, and by the time it was over, somewhere between 30 and 60 million people were dead. Most researchers now settle on a figure around 50 million, roughly 3 to 4% of the entire population of the planet at that time gone, largely from starvation, in the space of about 2 years. Climate scientists who've spent decades studying that event call it, without exaggeration, arguably the worst environmental disaster to ever befall humanity. And right now, in the second half of 2026, a new super El Niño is developing in the exact same stretch of ocean, growing faster than any event since scientists began tracking these cycles with modern instruments, already outpacing the last major super El Niño in speed of growth, and forecast to potentially rival the intensity of the 1877 event itself. Today, we're going to walk through exactly what happened in 1876, why it became so catastrophic, what's actually different and what's genuinely similar about the event unfolding right now, and why the honest answer to whether this could be even worse is more complicated and more important than a simple yes or no. Subscribe to the channel before we get into this, because I cover developing climate and disaster stories like this as the science comes out, not months after. The fact once everyone's already moved on. Let's start with the mechanics, because you need to understand what an El Niño actually is before any of this makes sense. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and allowing cooler, nutrient-rich water to rise up along the coast of South America. This creates a specific pattern of atmospheric circulation called the Walker cell, essentially a loop of rising and sinking air that governs rainfall patterns across a huge portion of the planet. During an El Niño, those trade winds weaken, sometimes even reverse, and all that built-up warm water sloshes back eastward across the Pacific instead of staying pinned against Asia. That single shift reorganizes the entire Walker cell, which in turn reorganizes rainfall patterns across an enormous stretch of the globe, not just around the Pacific itself, but through what scientists call atmospheric bridges reaching into the Indian Ocean, the Atlantic, and beyond. A strong El Niño doesn't just change the weather in one region, it can simultaneously suppress rainfall in some of the most densely populated agricultural regions on Earth, while intensifying it elsewhere, all at the same time. Now, let's go back to 1876, because understanding exactly how that event unfolded is the whole key to understanding why scientists are watching this year so closely. Researchers, led by climatologist Deepti Singh at Columbia University's Lamont Doherty Earth Observatory, spent years reconstructing what actually happened using tree ring records, historical rain gauge data stretching back over a century and a half, and modern climate model simulations. What they found was that the tropical Pacific had been running unusually cool for an extended stretch, from roughly 1870 to 1876, the longest sustained cool period on record at that point. That prolonged coolness allowed an enormous reservoir of heat to quietly build up in the western Pacific, essentially loading a spring under tension for years. When that system finally shifted in late 1876, it didn't release gradually. It exploded outward into what became the strongest El Niño humanity had documented up to that point. And critically, the Pacific wasn't acting alone. At the exact same time, the Indian Ocean was experiencing its strongest recorded temperature contrast. Between its western and eastern halves, a phenomenon called a positive Indian Ocean dipole, while the North Atlantic simultaneously reached record warmth for that era. 3 major ocean basins, all pushing global weather patterns in the same devastating direction at once. Researchers describe this alignment as a perfect storm, and tree ring data confirms that parts of Asia experienced their most severe drought in over 800 years as a direct result. The human cost unfolded across 4 continents almost simultaneously, and I want to walk through the actual regional breakdown, because the scale only becomes real when you see how it hit each individual region. In India, then under British colonial rule, an intense drought caused catastrophic crop failure across the Deccan Plateau starting in 1876. This became known as the Great Famine of 1876 to 1878. And it's a story that gets significantly darker when you understand that the region was still producing enough food to avoid mass starvation, but colonial grain exports swelled to record numbers anyway, actively shipping food out of a starving population for profit. Death toll estimates for India alone range considerably depending on the methodology used, from a careful demographic estimate landing around 8. 2 million, up through figures citing 12 to 29 million dead, with the affected region spanning 670,000 square kilometers and distress reaching a population of roughly 58. 5 million people. Famine relief for those who did receive it was almost sadistic in its inadequacy. Workers on relief programs, the so-called temple wage system, received just 450 grams of grain plus a single anna per day, in exchange for hard manual labor with no access to shade or rest. At the same time, in northern China, the same drought pattern triggered what's now known as the Northern Chinese Famine of 1876 to 1879, killing between 9, 5, and 13 million people, concentrated overwhelmingly in Shaanxi province, where an estimated 5 million people died, with another 5 million dead in Zili, now known as Hebei, and roughly 1 million more each in Henan and Shandong. In Brazil, the same global drought pattern produced what's remembered as the Grande Seca, a catastrophic famine that devastated the country's Nordeste region. And beyond these three epicenters, researchers found clear evidence of severe drought conditions extending into Egypt, Morocco, Ethiopia, Southern Africa, Colombia, Venezuela, and even Australia, and parts of southwestern and eastern North America. This wasn't a regional tragedy. It was a genuinely global one. And it remains, in the words of the researchers who've studied it most closely, the deadliest environmental disaster of the modern era. No climate-driven disaster since has come close to matching its death toll. So now let's talk about what's actually happening right now, in the second half of 2026, and why scientists are drawing this direct comparison, rather than treating it as an unrelated historical footnote. According to NOAA's Climate Prediction Center, El Niño conditions transitioned from a formal watch status to an advisory on June 11th of this year, meaning the agency moved from saying El Niño was likely to saying El Niño conditions were already confirmed and actively present in the tropical Pacific. The warming has continued accelerating rapidly since. Sea surface temperature anomalies in the benchmark Niño 3. 4 region averaged just under 1 degree Celsius above normal across April through June, then climbed to 1. 55 degrees by June alone, and by mid-July had reached 1 degrees. Forecast models are now showing strong agreement, drawing on 26 separate dynamical and statistical models, that this event will continue strengthening through the rest of 2026 and persist into early 2027, with most models now projecting anomalies exceeding 3 degrees Celsius by the winter peak, and some forecasts pushing toward the 4-degree range across the broader Niño region if current trends hold. As of the most recent NOAA analysis, there's now a greater than 90% chance this event reaches very strong, meaning genuine super El Niño, intensity during the northern hemisphere fall and winter. What's making meteorologists sit up and take particular notice isn't just the eventual peak strength. It's the speed. Analysis of the relative ENSO index, which normalizes data across decades so that different events can be directly compared apples to apples, shows this 2026 event has already grown faster than the last major Super El Niño back in 2015 and 2016, and it's already closing in on that event's peak intensity despite having developed over a meaningfully shorter time frame. Here's where I need to be genuinely careful and honest with you, because this is exactly the point in a story like this where it becomes tempting to just say this could be even worse than the deadliest disaster in history, and leave it hanging there for shock value. That's not responsible. And it's not actually what the available science supports in any straightforward way. There are 2 entirely separate questions buried inside that comparison, and they have very different answers. The first question is whether the raw physical strength of this El Niño, purely as an ocean and atmosphere phenomenon, could rival or even exceed the 1877 event. On that specific question, the honest answer is genuinely yes, it plausibly could. The growth rate and the projected peak anomalies coming out of current forecast models put this event in the same tier of intensity as history's strongest recorded El Niño events, and it's developing on top of a planet that's already carrying substantially more baseline heat than it was in the 1870s because of a century and a half of additional greenhouse warming layered underneath it. That combination, a genuinely exceptional El Niño arriving on top of an already warmed climate system, is exactly the kind of scenario that climate scientists studying the 1877 event have specifically flagged as a legitimate concern for compounding. Extreme weather, more intense drought conditions in vulnerable agricultural regions, more severe disruption to monsoon systems that hundreds of millions of people depend on for their harvests, and more extreme swings between drought and flooding depending on the region. But the second question, whether the human death toll could realistically rival or exceed 50 million people, is a completely different matter, and here, the honest answer leans considerably more optimistic, precisely because of everything that's changed since 1876. In the 1870s, there was no meaningful drought early warning system anywhere in the world. There was no global system for moving food from surplus regions to famine-stricken ones at scale. There was no satellite monitoring tracking crop stress and soil moisture in real time across entire continents. There was no coordinated international humanitarian response infrastructure remotely comparable to what exists today, through organizations built specifically to respond to exactly this kind of slow-building climate disaster. And critically, in India specifically, colonial economic policy actively made the 1876 famine dramatically worse than the underlying drought alone would have caused, by continuing to export food out of a starving population for profit, rather than directing it toward relief. That specific, deliberate policy failure doesn't have a direct modern equivalent in most of the regions most vulnerable to this year's event. Though weak governance, ongoing regional conflicts, and economic instability in specific countries can still meaningfully undermine drought response even with modern tools available. Modern agriculture also benefits from drought-resistant crop varieties, improved irrigation infrastructure in many regions, and considerably more sophisticated seasonal forecasting that gives governments and aid organizations months of lead time to prepare, rather than discovering a famine is underway only once people are already dying. As climate researchers studying this exact comparison have put it, modern tools including improved forecasting, global food trade networks, and emergency aid systems offer meaningfully greater resilience than existed in the 19th century, even as ongoing global warming continues to raise the baseline severity of the droughts themselves. So what does this actually mean for the months ahead, and what specifically should you be watching for as this event continues developing? Strong El Niño events reliably produce a fairly well-understood set of regional impacts, and this one is already tracking along those familiar lines. Southeast Asia and Indonesia typically see suppressed monsoon rainfall and elevated wildfire risk during strong El Niño years, since the shifted Walker circulation pulls rainfall away from that region. Southern Africa commonly experiences drought conditions that stress both agriculture and water supplies across multiple countries simultaneously. India's monsoon, which hundreds of millions of farmers depend on directly for their livelihoods, tends to weaken and become less reliable during strong El Niño years. Exactly the same regional pattern that proved so devastating in 1876. Parts of the Amazon and northeastern Brazil often see reduced rainfall and elevated drought and wildfire risk as well, echoing the Grande Seca pattern from the historical event. Meanwhile, other regions see the opposite effect. The southern United States, from Texas through Florida, typically experiences a wetter than average winter during strong El Niño years, while the Atlantic hurricane season gets actively suppressed, which lines up with what NOAA has already been forecasting for the remainder of this year's hurricane season. Australia frequently sees an elevated risk of severe drought and bushfire conditions during strong El Niño years as well. I want to be direct about why this distinction between physical intensity and human toll matters so much practically, because it's not just an academic point. It's the entire reason this kind of advance warning is valuable in the first place. If scientists simply threw up their hands and said this event might replicate the deadliest disaster in modern history, full stop, without the added context, that message would either produce paralyzing fear that helps no one, or it would get dismissed entirely as hyperbole once it inevitably doesn't produce 50 million deaths, undermining trust in legitimate climate science the next time a genuine warning matters. The actually useful version of this story is the one where we understand precisely what makes the underlying physical trigger comparable to 1876. Take that seriously as a driver of genuinely severe regional droughts and floods over the coming year, and simultaneously recognize that the outcome for actual human beings depends enormously on decisions being made right now: drought monitoring funding, humanitarian preparedness, agricultural planning in vulnerable regions, rather than treating the outcome as somehow predetermined by the ocean temperature alone. The 1876 famine wasn't purely a natural disaster. Researchers studying it are explicit that political and economic failures, the breakdown of traditional water and grain storage systems, and deliberate policy choices turned a severe drought into a historic mass mortality event. That's precisely the lesson worth carrying into this year, that the meteorological trigger and the human catastrophe are not the same thing, and the gap between them is where preparedness, governance, and international cooperation actually make the difference. If you want to actually follow how this event develops, rather than just hearing about it after the fact, the Climate Prediction Center publishes an updated ENSO diagnostic discussion on the second Thursday of every month. And that update will show you in real time whether this event is tracking toward the upper end of forecast intensity or moderating. Regions most exposed to this year's El Niño pattern, particularly across South and Southeast Asia, Southern Africa, and Northeastern Brazil, are exactly where humanitarian and drought monitoring organizations will be focusing attention over the coming months, and it's worth paying attention to reporting coming out of those specific regions as the Northern Hemisphere winter approaches and this event reaches its projected peak. I'll be tracking the Super El Niño closely as it continues developing toward its forecast winter peak, and I'll bring you a full update the moment the Climate Prediction Center's monthly discussion shows a meaningful shift in either direction, whether that's this event continuing to intensify toward record territory or beginning to moderate ahead of schedule. This is exactly the kind of slow-building climate story that deserves ongoing coverage, rather than a single dramatic video and then silence, because the real story here isn't going to be told by any single headline. It's going to be told by how the world responds to a genuinely serious warning over the next several months. Subscribe so you don't miss that follow-up, and drop a comment below letting me know what region you're watching most closely as this event develops, or if you've read anything else about the 1876 Great Famine that you think deserves more attention. I read every one of these, and a story with this much historical weight genuinely benefits from more voices helping dig into it. Stay informed rather than alarmed, because that distinction is exactly what turns a warning like this into something useful instead of something paralyzing. I will see you in the next one.